One more time.
Sure. So it says here, if the campers at Camp Grilled Meat prefer hot dogs to hamburgers by a ratio of 4 to 3, and they will need 500 hot dogs, how many hamburgers will they need? How do we set that up? How do we set up that question? How do we answer this?
Well, I took the ratio and tried to get it down to 1.
Okay.
So I divided the hot dog part by 4 and then the hamburger ratio by 4, which gave me 1 to 0.75.
Okay.
And then I multiplied each side by 5 to get my answer.
What did you get?
I got 500 hot dogs to 375 hamburgers.
Okay, good. All right, that is definitely one way to do it. I'm going to show you what I think might be an easier way. We'll see if you think it's easier. That'll be up to you, I guess, if you decide that that's easier. But normally what I do is I just, use my proportions, right? Like I said, most of the GED test is proportional reasoning. And so here we have a question where it's really easy to use proportion. We have a ratio of 4 to 3, and we set that equal to the information that we have. So we know that we have 500 hot dogs. We're trying to figure out how many hamburgers we need. So if this is our ratio,
So you
right?
cross
4 to,
multiply.
yeah, and you just cross multiply, exactly. So then we have 4x is equal to 1500. And then when we divide both sides by 4, we get x is equal to 375. All right. So this is like a great example of just using your proportion and using your proportional reasoning skills, right? You are given something that is true, and then you're given something else that is true, but you're missing a part. Then you just set those two things equal, and you just cross multiply to solve. Okay. Cross multiply, set the cross products equal to each other, and then divide to get your missing value. All right. So x is 375. All right, I have a couple other GED questions we're going to practice on today as well. Let me clear this and then move on to the other two. So we have a couple more. All right, so this is a class with 28 students, has 13 boys. What is the ratio of girls to boys in this question? Here, class has 28 students and 13 boys. What is the ratio of girls to boys?
$15 to $13.
Yep, that's it, right? Always make sure that you are reading your ratio correctly. That's really what this question was about, right? Whenever it says, whatever comes first, that's the number that should appear first in your ratio. And of course, you can write it as a colon, you can write it as a fraction, or you can write it using the word to. None of them are preferred over the other. They are all the same, but always make sure that if it's at whatever it's asking for first is what you list first. So girls to boys means there's going to be 15 girls to 13 boys, right? If this was a situation where this ratio could have been reduced, it was going to be your responsibility to put it in the most reduced form, but this one cannot be reduced, right? 15 and 13 can't be reduced. All right, and then our last question here. We had a question?
No.
Okay. And then last one is Bill from Bill's Burgers raises the price of his bacon cheeseburger by 15%. If the old price was $6, what is the new price?
That's my answer.
Okay, what's your answer?
$6.90.
Very good, right? So this question is a rate question. In rates use percents. When we are using a percent, we just take the percentage turn it into a decimal by moving 2 places to the left. We're going to multiply 6 by 0.15 to get 90 cents. So that is the amount that is increasing. So the new price means that I have to take the old price and add the increase. So that means I'm going to get $6.90. Very good. All right, so it's just a basic overview of some of the questions we might be able to tackle today, and hopefully get through and give you guys a more knowledge about those topics so that you feel more comfortable. All right, okay. I'm gonna go into our folder, into our Schoology course, and I'm pretty sure I made this folder red, and this red folder is like the probability, proportions, rates, and ratios. It's everything in this one folder, but that's what we're going to go into now. Let me just switch my view so you guys can see that. All right, so we're going to go to courses, GED Prep Math. And yes, this folder is red, probability, proportions, rates, and ratios. That's the red folder that we're going to work out of today. And you'll notice that I tried to put just everything in there because they're all very related. You use ratios to talk about probability. You use ratios to do rates and proportions. So they're all very related. And then I tried to put some of the related topics together. You use simple interest, for instance, when you're doing rates. And proportions also involve proportional reasoning, which has a lot to do with proportional geometry. So I added some things in there as well for that. Tried to cover all of our bases for all of the different things that are involved there. So hopefully you guys will have enough to kind of work with, go through, and then get ready to ask me questions. Of course, Sue's not allowed to ask me any questions because she's ready, right? You're ready? Tomorrow's the day, right? So you're totally ready.
I'm ready.
Okay.
I'm ready.
Okay.
My test is actually scheduled for November 1st, so
Okay.
I have some extra days to
Okay, good.
practice, but I know I need to go over graphs. I need to go over factorization for some. I don't remember doing that.
Remember how to factor?
Yes, I know. It's just I don't remember how to do
Oh
that.
my goodness.
So
Don't worry. There are enough Khan Academy videos that will get you caught up very easy. Factoring is actually not as difficult as you may think. So yeah, as long as you do
Khan Academy said that I did the exercise, but I don't remember. I think it's just I'm anxious. That's it.
That's all it is. That's all it is. You're like, what is factoring again? I don't even know what that means. Oh, okay. Right. That's what that is. All right. Yeah, I know how to do that. I know. Wait, how do I add with decimals again? Oh, right. Okay. Yeah, I know. It's yeah, you're gonna feel that way. But that's Monday, so it's not a ton of extra time, but it is a little bit of extra time. So that's good.
It's enough. It's enough.
Okay, good. All right, so I'm just gonna go over this general resource at first. So this is the first thing that's listed in this folder is ratios and proportions resource. So it's just a general note sheet that kind of highlights everything. And as we go through the items, let me know if you guys just need extra practice on that, and then we'll just skip to that resource and work through that. But I wanted to give us a good high-level overview and a good reference material to use. So that's what this first resource here is. Like I said, it's just general notes. So I'm just going to open that up. First thing it starts off with, of course, is vocabulary. It's always a good idea to start with vocabulary. It's a good basis for everything if you just know what you're talking about, right? You know what a ratio is and how a ratio is different from a proportion, and how a ratio is different from a rate, right? So who can tell me basically what the difference between a ratio and a rate is? Just really basically. What are we talking about when we're talking about a ratio versus a rate?
ratios have have the same unit measure and rates have different ones?
Perfect. That's it, right? So that's what we need to understand there, right? So a rate is going to be something like speed because we have miles per hour. Sorry, my internet is being okay, great. All right, so a rate is like miles per hour, like your speed or your heartbeat. That's a rate. But a ratio is when you're comparing two things that are similar. So students to students, people to people, right? Cups to cups. If you're doing like a recipe, all of that would be a ratio. But a rate is when you have two different things. So prices, speed, heartbeat, those would be considered things that are rates. Okay, very good. And what's a unit rate?
A ratio that is written as the same number to one. Can you explain that further?
All right, so your
different words.
A unit rate, the classic example of a unit rate is a price, right? A price for a single item, because it's how much you are paying for one thing, right? If I buy a 6-pack of Coca-Cola, right, that is not the unit rate, that is the price for the 6-pack. If I divide what I paid by 6, that is my unit rate, how much I paid for each can of Coca-Cola, for instance, okay? So that's
okay, so I have a question. So if you're like on Amazon or something, and it has like, it'll help you compare price per ounce.
Yep.
Is that an example of a unit rate?
Exactly, yes. Also in the supermarket, like on your price tag, there should also be a price per ounce to help you comparison shop. And that's like a good way to decide whether or not a sale item is actually a sale item, because you can use that to decide if that price per ounce is actually in fact cheaper than the other brand. Most of the time it's not, unless it's the store brand. That's the only time it's actually cheaper. Okay, but yes, price per ounce is an example of a unit rate. And we have to use unit rates whenever we're comparison shopping. So I think in the rates folder, there's a, like a warm-up question based on that same idea, like you have to use a unit rate to compare different things. Okay. So we know that a ratio can be written any of the 3 ways, right? As a fraction, using a colon, or with the word to, okay? And we always compare the same unit when we're talking about ratios, right? That's very simple, very straightforward. We need to go over that. A ratio table, right, is actually the basis for what you're going to use in things when you go up to graphing, right? A ratio table is going to be that exact same idea of where we're going to get to when we get to graphing. We're going to have X versus Y, right? As X increases, Y should increase. That's a proportional arrangement. And that's what ratio tables are trying to show as well, right? If I have 2 boys, I'm going to have 3 girls. So if I have 4 boys, I have to have 6 girls, right? This is a proportional relationship, and that's what this ratio table is showing me. As I increase my number of boys, I have to also increase my number of girls, but by that same ratio. It's always going to be 2 to 3. Whatever I started off with, that ratio is always going to be there. So if I'm missing any of the values, but if I'm missing, like for instance, one of the data points where I'm like, oh, I know I have 30 students and I have 12 boys, and I should be able to figure out that I have 18 girls, right? That's the idea behind the ratio table, because it's just taking the value of that proportional relationship. And again,
and I have a question. This is where you use cross multiplication?
Correct. Yeah, absolutely. Right. You can use cross multiplication, or you can use, in this case, because you have so many options actually. So like I know my ratio is 2 to 3, right? And I know that I have 12 boys. So how many girls do I have, right? And you can cross multiply in that situation, right? But also because they've given us the totals here, the other thing that I can do is that if I know I have a total of 30 students and 12 of them are boys, I can just do 30 minus 12 to get the 18, right? So it really just depends on the information that I have. But if I have the entire ratio table and the only data point that's missing is the 18, I can figure it out using subtraction, right? Pretty easily. Or I can use my cross multiplication of my proportion. Okay. Yeah, so ratio tables are like the most basic version of using proportional relationships. And it's just showing you that as one side grows, the other side also grows. Or it could be that as one side decreases, the other side also decreases, depending on how you read it. But they are proportional. Okay, so let's use proportional reasoning, right? The idea again here being, I can always find the missing number by using this proportion idea, right? You may have seen this before if you've done equivalent fractions or equivalent ratios. This is the same idea. Equivalent fractions or ratios use this idea of proportions and proportional relationships. If I have a fraction that is 24 over 36, but I want to make my denominator into denominator of 12, well, how do I get from 36 to 12? I have to divide by 3. Whatever I do to the denominator, I must also do to the numerator. That's the kind of idea that we're working with when we're talking about proportions. Everything has to increase and decrease by the same value. If I have 5, 6, but I need to make it into a fraction where the denominator is 54, I have to multiply 6 by 9. Whatever I do to the denominator, again, I must do to the numerator, right? That's how these relationships work. So you've seen proportions before, even if they weren't called proportions when you saw them. But anytime you had to make an equivalent fraction to add or subtract, you have used proportions. You've used proportional reasoning, right? And so that's why that's, a big deal, is because of how much it can be applied across mathematics. This idea of using this proportional reasoning and just going from a smaller variety to a larger or larger to a smaller. Okay. So we're gonna be using a lot of that idea. All right. Unit rates. We had just discussed this a little bit, but a unit rate is just a rate out of 1. Whenever I see the word per ounce, per package, per dollar, whatever, I am definitely working with a unit rate. Okay. If I'm talking about my typing speed, I type 95 words per minute, right? My heart is going 180 beats per minute, whatever that situation is, that per is, and that means I'm dealing with a unit rate, okay? To find a unit rate, if I have something that is bigger than a unit rate, I just have to divide the denominator into the numerator, right? So if I am trying to figure out how much my venti espresso caramel with double shot, whatever, how much it costs per ounce. Well, I know that in a venti, it is 20 ounces. And I've just paid $5 for my coffee. So the price per ounce is I have to divide that $5 by 20, right? That's how I'm going to figure out how much this coffee drink costs me per ounce, right? And when I do that, I'm going to figure out that it was 25 cents per ounce for my drink, okay? So whenever you are asked to find the unit rate, if say it's not written like a fraction, right? It's going to be written out in words. And it's going to ask you to find the blank per blank. You always divide the first number by the second number. So second number is on the outside, first number is on the inside, right? So this per is going to mean, in this case, you need to divide. It's like so whomever traveled from this place to this place in 900 916 miles. It was 916 miles or whatever, and it took them 4 hours. Like, what is his average miles per hour? Then I have to divide 916 by 4, right? Those are the types of questions that we're going to see. If it asks me for miles per hour, that means I need to divide those miles by that hour. Or it says that it took me, or I only used 24 gallons of gas on that trip, right? That means I need to divide the miles per gallon, right? I need to figure out what my mileage was, what my miles per gallon rate was, right? This is how we do unit rates. And there is some unit rate work as well in that rates folder. Are there questions or concerns about unit rates?
No.
Nope. Okay. Cool. More examples of unit rates and ratio tables. I think we got those. Okay. All right. Let's see if we can solve a couple proportions. We have a couple of examples here. Example 1 and example 2, right? Apparently 2 gallons cost $5.40. How much does 5 gallons cost? If I can travel 110 miles in 3 hours, how many miles can I travel in 4 hours? Okay, so you guys get me those answers. What do I need to do? So how would I set up the proportion for example number 1?
I put 2/5 times $5.40 over X.
Okay. So equals, right? You're using an equal sign,
Equal.
but then you're cross multiplying. Okay. Would it have been wrong for me to set it up like
Yes.
this?
Yes, it changes the entire thing.
That's it?
Or no, it doesn't. No, it doesn't.
Yeah, so just so you know, as long as you're consistent, right? So if I want to keep my gallons across the left, or if I want to put them across the top, as long as it's consistent, as long as we're not switching places by putting them diagonally from each other, then we should be able to get the same answer. Yeah, as long as it's consistent. They either need to be vertically aligned or horizontally aligned, but either way, you're going to get the same answer. Okay, good. So when I cross multiply, I'm going to get what?
You're gonna get 2X and 27.
Okay. Okay. Right. And so as the Tia said, then my answer is going to be 13/5. Okay, for my X. And then you're going to get 146.7 miles for the other one. Is that true? It looks right. Good. All right. Nice.
Mm-hmm. It's like 146.66666.
Yep.
It's 7.
Perfect. All right. So we're doing good with the proportion. Yes, just find the round. That's exactly what you should do. You should round in that case. Let's scroll on out. Okay. All right. So the other thing that we use proportional relationships for are for geometry comparisons, right? And we're going to use this dog drawing kind of as an example, right? We see that this is a quote unquote scale drawing of the real dog, if you want to make it seem that way, right? So we have that the head length is 10 in the drawing and it's 15 in the real dog, right? We have to make sure we set up those proportions exactly and figure out the pieces that are missing. Now, if we try to do the same thing here in this example, again, all we'd have to do is cross multiply and divide to get our answer, right? So we just do 10 times 42 and then divide it. So it's 420 divided by 20 to give us our answer, right? Of 21 for the actual length that we're looking at here. That's what we get. If we put it down, yep, we get 21 wrong. So I'm going to show you guys a couple examples of that before we get into percent. Let me just go back here. So back into our folder, a nice red folder. So if we go into proportions and proportional reasoning, there's a proportional geometry document. I'm going to pop open right now. Right, so this is kind of the example that you're gonna see a couple of these on this test, right, where we're going to be using proportional relationships to solve these kinds of things. They're unfortunately not going to be quite this simple. They're probably going to be more like 20 plus x and 12 minus x or whatever, but it's the same idea, right? As long as you set up this proportion correctly, you're going to get the right answer. So just go ahead and set this up. If I set it up, what would it be? What would it look like to set it up, put this up correctly?
20 over 12 equals 30 over n.
Okay. All right, that's great. You can also do 20 over 30 is equal to 12 over n, right? Any of those is fine, but yes, as long as you set this up correctly, you're going to be able to solve it correctly. So remember to just, work through that and do that as quickly as you can when you're working through those on the test. It's probably going to be in the non-calculator portion, even if you do have like 20 times x plus 1 or whatever the situation is. But remember to set up your proportions, and that's how you're going to solve these types of questions on your test.
Can you go over how we would solve a proportion that has a variable?
Sure. Okay. Let's see if I can pull it up here. Let's see. All right, here we go. Here's one that we can use. Um, so right now we're just trying to I was just getting something set up. So now we're ready to look at this problem here. Okay. So we have the information telling us that AB over B is equal to AC over CE. We need to find the length of BD. All right. So we can set up our proportion. It's already set up. So what we're going to do is just fill in these numbers that we have for A and B. I don't know if this is like the best solution, but anyway, AB we have 16, BD is X, CE is 10, and then AC is what?
30?
What's AC? Remember we have,
It's 20.
good. All right, so this is just a smaller example of what you would be doing normally. But again, this one is set up pretty easily for us. It's just 160 divided by 20. Just to kind of get us warmed up. We just divide both sides by 20. But yes, we have to make sure that we're looking for really, especially when it comes to these drawings, right? We have a tendency, if we're going too fast, we're gonna be, oh yeah, it's 30. No, this measurement's from A to E. We have to be very careful about that. When we cross out our 20, of course, we're going to get.
That's what you're going to get 8. My biggest issue is rushing. Like, I did it when we were doing working through distributive property where I forget to do one side.
Yep.
But it's just like I get so anxious about seeing everything that I forget to like calm down.
I think that, and there's a lot of test taking anxiety, especially when it comes to the GED test, because you are timed, right? And you know that you're going to run out of time if you waste, quote unquote, waste your time. I will say though, it is worth it to make sure that a question that you've worked on is correct, right? Versus getting to the next question, right? Because who knows what the next question is going to be. So if you know how to solve this question that you're currently working on, work on it, right? And then skip to the next question and see if you can work to that on that one and give that one time. What I will say is that right at first, if you know that's going to take you too much time and you can't remember right away to do a question, skip it, right? Flag it for review, skip it, and then come back to it. But don't sit there like for 5 minutes, like, how do I do this again? That's what you don't want to do, right? Don't pause and think about how to do a question. If it's not coming to you immediately, skip it and come back to it. Like you know, it might something else in the test might jog your memory and then you can go back to it. But do not sit there being like, oh wait, I know how to do this. Let me think. No, then you're wasting too much time. So just focus on a question and focus on getting it right versus rushing to get it right. Okay, let's see.
It's gonna have to repeat patience is a virtue over and over again on my test day.
Yes. Yeah, exactly. You would definitely have to do that. All right. Okay. Let's see if I have another one. It's a little bit more engaged. That is a little too simple. What a nice complicated. Okay, let's try this one. Here we go. This will work. All right, so given the situation that's given, right, can we find the value of x, right? So basically we have to set up a proportion and then solve for x. So it says the triangle FGH is similar to the triangle JKL. So what does that tell me? It tells me that my proportion should be set up so that I am saying that FGJK is equal to GHKL, right? So I need to just put my numbers and my values in for the proportion that I set up. And if you set it up differently, it's okay, as long as you're consistent again, and then make sure that you are following what your setup is. So the measurement of FG is 3x plus 2. The measurement of JK is 5x minus 2. The measurement of GH is 5x. And the measurement of KL is 7x. So again, I do the same thing that I would before in a regular proportion, even though this one is a much more complicated situation. I'm just going to cross multiply, right? So I need to multiply this 7x to both of these terms. So what is 7 times 3?
21.
21.
Good. And x times x is x,
2x.
x
Oh, to the
squared.
second power.
X, yep, good. All right, and now 7x times 2 is going to give me 14x. Okay, and I have to set that equal to my other cross product. So now I'm going to multiply 5x times 5x. It's going to give me what?
25x to the
Oh.
second power.
Yeah.
Perfect. Minus 10x. So next, I'm just going to try to combine my like terms. So I want to combine my x squared term and my x terms together. So since my x term on the right is negative, I'm just going to add it to the left so that I don't have to deal with the negative term anymore. So I'm just going to add 10x to both sides. To give me 21x squared plus 24x is equal to 25x squared. And then I'm going to subtract the 21x squared from both sides because I would like to simplify and keep my everything nice and even. So I'm going to end up with 24x is equal to 4x squared. All right. So now comes the tough part. Now I got to solve for x, even though I have an x and an x squared value. So what I'm going to do is, oh, you know what? I'm not going to do anything, actually. What Sue's going to do is Sue's going to factor for us.
All right, I'll give it a try. Where I'm lost again.
So we're at
I'm
24x
lost in the
equals 4x
X.
squared. So what do I have? What values do I have in both of those terms?
Four, or I mean X.
Yep, you have a 4 and you have an x in both of them. So that's right. Both of those things are right. So I can factor out 4x out of both of them. What that means, basically, I can essentially divide out 4x out of both of these terms, right? And I'll still be left with a value,
Or on both sides.
right? So I can divide out 4x on both sides. If I do that, right, if I divide both sides by 4x, right? Because it'll help me get rid of a term, right? What am I going to be left with? 24x divided by 4x would be what?
6.
6, okay? And then 4x squared divided by 4x would be equal to what?
X.
X. That's how I'm going to find my answer, just by factoring out. It was just that simple.
I don't know about simple, but
So we can check to see if this works by plugging in the value of x that we just found back into these proportions here. Sorry, I lost my picture. Here we go. Stay on. Okay. We can try to see if this works. What we can do with that 6 is plug it in. Okay, we'll plug it in into our equation. So we have what? 3 times 6 plus 2 over 5 times 6 minus 2 is equal to 5 times 6 over 7 times 6. Now, in order for this to be equal, our cross products would need to be equal. So we need to see if we can figure out what our cross products will be. So of course, this is going to be, I'm going to erase some of this other information so that I'm not overlapping. All right, what we're going to end up with is 18 plus 2, so we have 20. 30 minus 2, 28.
28.
Equals 30 over 42. And then when we cross multiply, did we get the same answer? When we cross multiply out of both of these? 28 times 30 and 20 times 42?
28. Yes, we do.
That means
We
6
get
is correct.
840.
That means 6 is the correct
Yes.
answer. Okay. All right. We checked for whether or not proportions are true by cross multiplying and getting the same response. If we get the same response, then it means the proportions are in fact correct. So that's how you check a proportion. And so that worked out. Yes. Good job on factoring, even though I put you on the spot. It worked out. Good work. You got,
It was all Latia.
yeah, you got a great, I was about to say, you got a great assist from Latia. Latia definitely helped out there. Okay, so good work, good work. Yeah, but again, factoring is just seeing what you have in common, remembering that a factor, right, is every part of a multiplication product, right? So what do I need to create 4x squared? I can create 4x squared in a couple different ways, but one of the ways is multiplying 4x times x. That's how I end up with just x being left, because 4x times x gives me 4x squared. How can I create 24x? Well, there's a couple different ways to create 24x, but if I'm dividing by 4x, then the only other thing that will be left to create 24x would be 6 times 4x. That's how I get 24x. That's how I know I'm left with 6. Okay, so when you're factoring, you're just trying to figure out what makes up the number that you have, right? What gives me a product that ends up with this number? That's kind of one way to think about it. So what are my parts here that I can use? All right, so let's see if there's another one we can work on.
It's coming back to me. Like the tree that you use to break down with numbers, create a number.
Correct.
So you
Yep.
do like a prime factorization of 4 would be like 2 times 2, right?
Mm-hmm. Exactly.
All right.
That's the factor.
It's coming back to me. It's just anxiety. I just got to tell myself it's anxiety.
It is a lot of anxiety, but that makes sense though, right?
But after this, I'm done. That's all I got to keep telling myself is that after this, I'm done, and then college.
Exactly. All right, let's try another one. Before we try another, how does this class compare to your regular math class?
My math teacher has been having some problems, so he's just been assigning us stuff on Khan Academy.
Okay.
Like some problems with his computer.
Mm-hmm.
But how would I explain this is different? Your teaching method is a little different.
Okay.
But I think it's.
Go ahead.
But I think it's due to you having a smaller class size. Like I feel like I'm able to remain more engaged, and also I feel like we're challenged a bit more in here. But
yeah,
that's a good thing.
Yeah, I think that the content's definitely going to be different, right? But I was just trying to figure out like if you guys are getting some of the things that you need still from that regular class, like if they're covering enough that you feel like it's beneficial.
Yes.
Yeah. Okay, good. Same for you, Latia?
Yeah, well, in my math class, I don't know. Everybody get off track in it. They don't really be talking about math in that class.
Oh no. But that's what you need math. You gotta get it back on track, Latia. You gotta get
I know that's why, and honestly, I have my test on the 4th. I'm just trying to hurry up, study as much as I can for real. The main classes that I take is like the GED oscillation class. I just take you and Miss Bates,
yeah,
because my regular classes, they read too much. Like they just get off track, they talk, and then my math teacher, she let the class operate the class. Like she sit right here and put up a problem. And I mean, it'd be a good method to use to let the kids discuss it and try to work it out. But it'd be also frustrating because if no one didn't go over it or review it before, so now everybody taking turns guessing, getting frustrated, calling her name, telling her, okay, it's time for you to tell us these answers. I'm just like, I can't. So my main focus is trying to hurry up and get study from this math test that I have on the 4th, so I can hurry up and take it, hopefully pass, so I could not have to take her anymore at all.
All right, I got that. All right, here is a challenging one. So we're gonna need a couple of things in order to solve this. Do you guys remember the Pythagorean theorem?
No, I just looked at it recently.
You do not have to remember it, don't worry. It is going to be on your formula sheet. Again, always use that formula sheet, but the Pythagorean theorem says that whenever you have a right triangle, and I'll just tell you right now that this is a right triangle, even though it's not indicated, but it should be indicated with a little box here. Whenever you have a right triangle, you're going to have this to be true. A squared plus B squared equals C squared. And C squared is always the longest end, which is the end that is opposite the right angle. And then the other two, it doesn't matter which one you call A and which one you call B, but just the other leg squared plus the other leg squared is going to be equal to the value of the third leg, the longest leg squared. So the first thing we need to figure out is the length of this longest leg, because that is going to be able to give us the value for y. Okay? So we have to use the Pythagorean theorem first. So what is the length of leg A? And we'll call this leg, leg A. What is that length?
12.
Good.
Is it 12?
Yeah, it is 12. All right, so we have 12 squared plus the length of leg B, which is 9. 9 squared is equal to C squared. So 12 squared is going to be 144. 9 squared is 81. So 144 plus 81 is going to give me 235. That right? No. Yes? No. 225. Oh, I should not use this, not do it in my head. I have a calculator, it's fine. 225. Yep. Okay. 225 is equal to C squared. So then now I have to figure out C squared by taking the square root of both sides. So I use my calculator again to do the square root of 225, which is 15. So the length of that whole side is 15. So what's the value of y?
10.
10.
10. Very good. Okay, so now you guys should be able to figure
The
out.
triangle is
I'm going to erase all my drawings on this triangle, but now you should be able to figure out the value of x. Okay, I'm just going to erase those circles to not confuse you. So now go ahead and figure out the value of x. Now that we figured out how to get 10, what is the value of x? Did we get a value for x? Ooh, I see somebody.
I took an educated guess and said 6, but I know that
Yeah, I think it's 6 too.
I know that to calculate the height of a triangle, it's 2 times area over base,
Okay.
but I'm trying to figure out what I should be plugging in. So I think the base is 12. So 2 times something over 12. And our area.
So the answer is definitely 6. And I will give you, I gave you actually 2
I did it so totally different.
Good. What'd you do? Yeah. What'd you do? That way that Sue did it was a little, that's too complicated. It's a much more direct way to figure it out. So what did you do this year?
I had I did 8 squared plus x squared equals 10 squared.
Beautiful.
And then once I totaled it out, it was 64 plus x squared equals 100. Yeah. So I minus 64 on both sides and got 36, and x to the second power. What I did, what's this called?
The square root.
When you yeah, got the square root of 36 and it was 6.
Beautiful. Okay, so that's one way, which is great that you use that way. The other way, of course, was to just use the proportional reasoning, right? So 10, oops, sorry. Let me just get my annotation back here. All right. So 10 is the same as 15, right? The length of y is the same length as BA, which is equal to x over 9, right? That's the other way to do it. You cross multiply, you get 90 is equal to 15x. And then you would be able to get that x is equal to 6. So that's one way, the proportion way. Sorry?
I wanted to cross multiply, but I didn't know exactly what to plug in. I think that was my struggle.
Right, yeah. So the biggest thing here, right, like especially when we're looking at these drawings, and this is like what proportional geometry is all about, is understanding that if this measurement, or like this, well, because it says it right here that both of the triangles are similar, I know that this measurement should be compared to the measurement that looks like it, right? And so that means that's how I know to compare those two, x over 9. And then the y has to be compared also with the same measurement, which would be the AB, which is 15, right? But again, you didn't have to do that because I just introduced you to the Pythagorean theorem. Using that was just as good as an idea as doing the proportional reasoning, right? But thinking any deeper than that, like trying to remember another calculation, that's where you went too far, right? Like use what you have, right? Either use the proportional relationship, right? Comparing what we have, or try to use the Pythagorean theorem now you've been introduced to it, right? But that's whenever you're looking at right triangles, right? Remember to like, oh, go to the formula sheet and look for the Pythagorean theorem, just in case, just write it down, just make sure you have it, and know that you can work with that as well, okay? The Pythagorean theorem is going to help you guys kind of plan and get through. Okay, I'm so glad I get to introduce you guys to new things. It's always fun for me. Even though I really should.
I have a question.
Yeah.
So I'm planning on studying computer science in college. Can you give me an explanation of what combinatorics is?
I mean, somewhat, but not really. I think it's just like, I did not study computer science. I was a science major, right? So, and I did not do computer science for this very reason, because like I have a vast knowledge of math and I love math, but like it stops, right? I'm just like, this is no longer interesting to me after this point, which is the point where you kind of get into this idea of being able to use like the theory of math into like making sense for technology, right? And that's for me, that's where like the lines don't cross. But select
Yeah.
really give you a good definition of what that is. Because like for me, it's just a little bit out of my scope.
I think math is challenging, but I enjoy it, so I'll be fine. I think I'll be fine.
Yeah. No, I mean, that's the thing. You have to really enjoy math and really enjoy like the theory of it. Like I like math. Like don't get me wrong, like, math is great. Like me and math are friends. But like when you want me to analyze math, I'm like, no, I'm good. Like I'm gonna skip this class. Thank you. So that's kind of what it was for me. Like I was like, I don't want to.
I think my brain automatically goes there. Like, why are we doing this? Why are you multiplying right here? Why? I think I'll be fine.
Yeah. Okay, let's see what else. All right, what time is it? So after 2. Yeah. All right, I don't want to get too far into the weeds with too many things, but let me just go over what's in your folder and what other things you guys can be exploring, and then I'll get kind of a general idea of what we might want to do next week. And when I say we, I just mean Latia and I, because Sue will be done because she will have passed. Just gonna put that out into the ether now.
I'm receiving it.
Okay, so again, in this red folder, that is hopefully not temporarily red, and I won't, we'll see. There's just some general practice on how to use ratios, rates, and proportions, like all of it together. There's a really great sheet that kind of gives you a quiz, not really a quiz, but like makes you go through all of these points so that you feel more comfortable with all of them, right? Ratios, proportions, unit rates, it covers all of it. And then it gets into word problems after. And yeah, it ends with that proportional geometry question that I showed you guys earlier. If you want to dive deeper into a specific topic, I tried to organize that as well. So there is stuff in probability which uses ratios, but it's not the same as ratios, but it uses the idea of ratios. What's great about the GED test is that it used to cover really theoretical probability, and now it doesn't. It really just covers the general probability stuff. So I put in some notes that will hopefully get right at the heart of that for you guys, so you don't have to dive super deep into probability. Again, proportions and proportional reasoning is in there. Rates and simple interest, this is the one that's the most elaborate. It has like a very step-by-step process of different things you can do, and even a recording of me going through the notes and filling out the notes with students. So that's also very helpful if you want to go through that. And then just a little bit extra practice on ratios, which the other things are all based on. So I don't think you need additional practice on ratios, but I put it in there just in case. So that's what's in that folder and what can help you guys out. Again, there's a bunch of other things in here as well, right? From exponents, other kinds of geometry and square roots. So if there's something that you want to go over, you might find it in here as well if you can't find it in Khan Academy. Also, do make sure you make plenty of use of Essential Ed. I'm going to go in here right now. You guys are going to watch me go in to make sure.
I can't figure out how to log in.
Okay, well, I'm going to double check that you're.
I'm missing the DC.
Okay, there it is. Good. And also going to double check to make sure your account is active, because it expires if you don't use it every month. Not expires, it just makes you inactive. So then I just have to, I'm going to go in right now to make sure you are active, and you're definitely not. Oh, you are. Oh, yeah, you are active. Oh. Okay. So you should be able to get in, and then I'm going to do the same thing with Latia right now. Yeah, you're also active. So you guys are good. So use essential ed as well to, just give yourself a chance to kind of study other things. I will kind of show you what it looks like if you haven't logged in yet. You kind of just join the course that you're studying, which is, your math or RLA, whatever. You can find the different lessons on things, like if you need to go over expressions equality, those kinds of things they're there. Want to go over geometry, it's there, and they give you these lessons and also kind of help to quiz you. But I think the best part of Essential Ed for me is the fact that you can take a practice test, right, at any time. So you come to this right-hand corner here and you can just take a practice test. And it allows you to kind of go through taking any of the practice tests. And especially with the math one, it's even more challenging than the GED Ready. So it's not there to discourage you, but just to remind you what kinds of questions you might see. The questions themselves are a little bit more challenging than you'll probably see on a GED test. So don't let that discourage you, but just try to remember like that topic. Like, oh, this topic is something that might come up. Be ready to study this topic again if you haven't seen it in a while. So it's a good idea to like go through here and use that as just extra pump and extra motivation to like do more studying or like find other things to study. All right.
All right.
Okay.
So it's like a diagnostic tool of what you need to learn.
Yes, absolutely. What else can I show you all today, and what should I prepare for next week, Latia?
I think Latia can answer because I'm not going to be in class next week. So.
Right. But is there anything else you want to see today, Sue?
No, I think I literally have my whiteboard and like things I need to study.
Okay.
So I have a list of things we went over.
Okay.
Things that I was getting a little lost on.
Yep.
And that I know I need to brush up on them. I definitely need to do geometry.
Yep.
Proportional geometry, graphs, expressions, equations, inequalities. Go over that again. Okay. Go over triangles, go over probability, and then practice slope.
Okay, sounds good. All right, so let's see. What am I working on?
All the words on my mouth. Basically the same thing that she said, but as I told you, I just need to revisit everything that is on the GED test, because guaranteed I know it. I just haven't did it in so long. So once I review it, go over a couple examples, I feel like I got it. So anything that we haven't covered so far, whatever is next, I'm ready for.
All right. What if we go through simplifying radicals on Tuesday? Does that sound good?
Oh, yeah. Yeah, that sounds good.
All right. So that'll be the plan for Tuesday. So we'll go over our roots and our radicals then and kind of go over those properties as well. That's also already in here. There's already a folder in here on that. So if you guys want to do it on your own as well, there is some stuff in there. We can go over it together on Tuesday. All right. All right. I'm, hopefully, I'm helping you guys out. I want to think that I'm helping you, but I don't know. I feel like we don't meet enough. And, I'm not like harping down on you to get work completed or anything like that. So it's really just like, I know that I'm providing you with stuff, and I hope you guys are doing what you need to do. And I just keep my fingers crossed that you guys pass these tests the first time out, because it's very, disheartening if I have to go do it again. I know that. So just, let me know. Don't always contact me if you need more, if you have a question, because I don't want you to go face this test feeling like you're not ready. All right?
All right.
Okay.
Got it.
Cool. All right. Well, then I will see you on Tuesday, and I'm hoping to hear the good news on Monday.
All right.
Okay. Have a good weekend, everyone.
Good luck on your test.
Thank you, Latia. I hope you do well on yours. I know you're going to do well on yours.
Thank you.
All right.
Yeah, between Mr. G and Khan Academy, I think I got it.
All right. Good. All right. I'll see y'all.
All right. Bye.